Welcome everybody. Thanks for tuning in today. So the last time I was here was back in September. I presented on the use of mass timber construction in the residential sector as a representative of Xlam Australia, so your local CLT suppliers. So you'll notice that I'm now wearing a different shirt, and I've joined the HESS TIMBER team full-time in Australia. So I'm here to support you all both technically and commercially, as well as acting as our local project manager for our live projects. So please, if you've got any questions, feel free to get in touch with us, or any mass timber projects that you'd like us to look at. You can find me on LinkedIn or contact me directly. So today's presentation is a case study on the HoHo building in Vienna, Austria. So I should say from the get-go that HESS TIMBER did not have direct involvement in this project. However, one of the companies in our group, Hasslacher Timber, was the main timber supplier. So the information in these slides was handed to us by our group, along with other key stakeholders who worked on the project directly. So in the lead up to this presentation, I was researching and understanding the HoHo project, generally leaning on my previous experience with mass timber, specifically in Australia. So what I found and what I was looking for was that this project has introduced some interesting and insightful items that we're probably not used to seeing here. So these I'm happy to share with you today. Firstly, I'd like to outline the program for today. So I'll be firstly introducing the development of HoHo itself, the team and the key stakeholders or suppliers of the project. Then I'll move on to the location and the setting within what they refer to as the urban development where HoHo is located, before then explaining both the architectural and structural designs or systems. And then lastly, I'll go through some of the prefabricated technologies that were used in the construction of HoHo, before then taking some questions at the end. We're also lucky today to be joined at question time by Georg Jeitler, who worked on the project firsthand. So Georg works at Hasslacher Timber, which is part of the same group of companies as HESS TIMBER operates within, known as the Hasslacher Group. So it's currently 1:10 a.m. for Georg, so thank you very much for attending, and hopefully we'll get some really interesting questions at the end, so we can share with you all. Right, so HoHo itself was completed in early 2019, and at the time it earned the title of the world's highest wooden hybrid building. The building is 84 meters tall and across 24 stories, and it consists of 4,350 cubic meters of timber fiber, and this is across all the timber products that went into the project. So it's important to note that the timber elements do support their self-weight and the imposed vertical loads for the entire height of the building. And it uses the concrete core purely for the lateral restraint purposes. So I'll go into this a lot more in detail later. Yeah, obviously it's good to know that the timber itself can sort of span that sort of height. So the construction brought together multiple prefabricated technologies across a number of suppliers. And these suppliers had to work with each other, not only from a design coordination perspective, as would be expected on any typical job, but in a much more intimate and collaborative way. So for example, the window suppliers set their frames to the CLT supplier for prefabrication before then heading out to site. So working in with each other was very important for the project. The installation, as you'll see as well, frequently swapped from timber columns and walls to precast edge beams to timber concrete slabs, and working in with the deliveries from an installation standpoint took very careful planning. Installation speed was 1 level per week, and the structure was made up of 75% of volume in mass timber products, with the remainder being the reinforced concrete, both precast and in situ, which I'll go through later. Also, the volume of timber used on the project was regrown entirely from the Austrian forest the timber originated from in only 2 hours. So 2 hours time to regrow that entire building, which I think clearly reinforces the undeniable sustainability benefits of mass timber construction. So the vision for this project and the development as a whole came from the developer Cetus Bau Development, which is represented by Carolyn Palfy on the left and their investor Gunter Körbler. The architectural firm was Rudiger Lehner, and the structural engineering was undertaken by the HESS Group. The main mass timber supplier was Hasslacher Timber, who supplied the glulam columns and the CLT wall panels. You can see here, so the columns and wall panels. These were supplied from their facility in Sachsenberg in Austria. The composite floor panels were supplied by Meyer Mallenhof from Wollersdorf, which is also in Austria. So that's these roof panels here. We'll go into more detail later, of course. The precast edge beams supplied by MABA. I'm not going to try and pronounce that second part there. And the windows supplied by Katzbeck. Katzbeck Windows and Doors, also from Austria. The location of HoHo is on the northeast of the suburb of Aspen, which is just outside Vienna City on the other side of the Danube River, which is where it's situated within the urban development. So the urban development is called Seestad, and it's taking shape over a decade plus long construction phase, which sees a combined population both in workplace and housing of 40,000 people. And the concept of the urban development is essentially to create a city within a city. So it's a self-sufficient precinct that includes all the resources and services one would need to live. So schools and businesses, homes, even medical centres and gyms, pools and outdoor recreation parks, shopping and dining, all that forms part of the master plan for the urban development itself. And at the core of the development is what's called the red string, which is a key link within the city. And this provides public spaces and transportation routes to connect all the areas of the city together. So HoHo is located in the center of this link, right adjacent to the train line. So right here is where HoHo is located. And this is the major train line, which has a station here, a Seestad station. And this train line connects back into the major train routes, which connect to the surrounding regions and into the CBD. So the architectural design was always focused on timber. You can see this clearly by the choice in the external color tones and the facade, as well as obviously the heavy use of exposed timber elements internally. Here's a few external shots and internal shots of the building. You can see these are actual images, so you can see just how much sort of warmth and brightness you get from the timber. These are renders at the top here, but again, pictures of the shared office spaces once completed. So environmentally, as you'd expect with the use of timber in such a heavy fashion in this building, these boxes have been ticked with a gold LEED rating, 2,800 tonnes of equivalent carbon dioxide saved by using timber for 75% of the structure. And this figure is based on the equivalent CO2 that a conventional building would have consumed if it didn't go with timber. And this is the equivalent of approximately taking 1,000 vehicles off the road for 1 year. We've now just got a short video on the development, which I'll present to you now.
At the heart of Europe, in Vienna, Austria, a showcase project is taking shape. On the bank of a beautiful lake, HoHo Vienna is set to become the world's tallest wooden high-rise. At 84 meters tall and with 24 floors, the groundbreaking construction will set new standards in design that is in tune with nature. Wood makes up 75% of the building that will draw on the natural resources from the region. A perfect example of sustainable and environmentally friendly construction. In just 2 hours, the wood required for the project will have grown back across the country. And upon completion, HoHo Vienna will have produced 2,800 tons of carbon dioxide less than a building constructed with conventional materials. That's the equivalent of a 50-kilometer drive from HoHo Vienna to Vienna Airport and back every day for 1,000 years. Vienna International Airport is just 25 minutes away, and the journey to the city centre is just as quick, for the underground is on your doorstep. When it comes to living standards, HoHo Vienna will deliver what the capital is already famous for. 8 years running, Vienna has been named as the city with the highest quality of living anywhere in the world. Visionary projects like ours will help keep it top of the ranking. The building will not only be a place for tenants to take a break and relax, it will introduce a touch of nature to everyday office life, supporting your work-life balance. For wood gives a sense of security and creates an incomparable level of comfort. The sun and water give wood its strength, and their positive energy can be felt in rooms made with this natural material. The innovative modular wooden construction is also incredibly flexible. Interior design is simple, and it can be quickly adapted to satisfy the customer's needs, making HoHo Vienna both versatile and functional. Sustainability is nothing without safety. A core made of reinforced concrete provides the tower with structural stability, while fire safety is significantly higher than in other high-rises. After 2 years of planning and a further 2 years of construction, HoHo Vienna will open its doors to residents and visitors at the end of 2018. 24 floors offering a whole host of new opportunities will make them feel more than welcome. HoHo Vienna. We are planning for the future. Modern, urban, sustainable.
All right. So this term here on the screen was an architectural expression that drove the design of the interior spaces. The intent was to provide a purely natural environment, so a place of relaxation, whether you're at work or simply using one of the various facilities within the building. As some of you may know, it has been shown that working and living and even recovering in natural spaces like these timber buildings can have health benefits like reducing blood pressure, lower stress and anxiety, and just improve the overall health and well-being. And this was a clear message that the designers of HoHo wanted to tell. So the building operations vary as you ascend upwards. So we start at the base of the tower with a commercial precinct of shops and restaurants. Above this sits the wellness centres, gyms, health and beauty centres. The office and co-working spaces then sits above that, and that's essentially the heart of the precinct, so the primary operations of the building. And then finally, the hotel and service departments on the top portion of the main tower. I should also mention now the adjacent building here, which is referred to as HoHo Next. This is a 6-story building, which is essentially dwarfed in comparison to HoHo, but would be a substantial mass timber building by any normal standards. And this was unique because it was used as a pilot project for HoHo itself, the main building. So Next was built immediately prior to HoHo, and it was used to test all the structural systems to get further efficiencies and to really understand the instruction methodologies, so that when it came time to start the main build, there was nothing holding up progress, and they knew exactly what they were doing. The facade development, this was quite another interesting process that they used. So in order to replicate the natural form of trees and forests, The architect used images of these trees and forests, which they pixelated into orthogonal shapes before then applying it as a skin over the building. So they then generated a natural color tone of browns and light browns and dark browns, and varied this tone across the height of the building in relation to the contrast of the pixels. So the darker the pixel, the more darker brown it became. The lighter the pixel, the light brown. You can see this clearly on, if you look carefully here with the facades, you can see this is actually mapped from trees. So each pixel or block was generated through that design process. I thought it was quite interesting. So structurally, the building, obviously 24 stories, 84 meters total height. The primary construction materials are a reinforced in situ concrete core, glue laminated timber columns, CLT or cross laminated timber walls, precast concrete edge beams, and timber concrete composite floor panel. So a bit of a Frankenstein building in many different aspects with different materials and suppliers that supplied the project. So the lateral restraint is taken up by the concrete core. So both X and Y direction on the left here, this is the split out of the concrete. The timber structure then is horizontally docked to the side of the concrete core, which then provides the vertical load and self-weight of the structure. So like I mentioned before, the timber itself spans the entire height of the building. So the geometry and slenderness of this building, for whatever reason, it was not economical to provide a lateral restraint system from timber, hence the choice in concrete. However, as we've seen with other buildings, building designs and early concepts, that a tower of this height, obviously depending on the form factor, can be realised purely in timber only. Obviously, in this project, it wasn't like that. So this shows how the timber and the timber composite parts were assembled as a kit of parts on site. So this is sort of Austria's response to Sweden's IKEA. It was prefabrication, but on another level that we don't really see here in Australia. So we're well used to mass timber buildings and inherently how simple and speedy they are to install. Though this is normally driven by a single supplier. So for example, a CLT supplier will document and supply their products and associated fasteners to site for someone else to take over and do the install. But this was the CLT, the glue lam, the precast concreter, the window suppliers, facade companies and installers all really supporting each other along the whole way. So HoHo saw a collaboration across multiple businesses and materials to each sort of combine on site in a seamless and integrated fashion. So here you can see a breakdown of the segments which attach back to the concrete cores. The timber concrete composite floors at 2.5 meters wide, and they clear span up to 7 meters. The precast edge beams were typically 400 by 600 and are connected with horizontal tension ties together. The timber columns are made from GL32 glue lam, and they range from 400 by 400 all the way up to 400 by 1 meter. And the wall panels are then cross-laminated timber plates, which are exposed internally and then externally with the thermal insulation and a facade plate on the outside. Designed for progressive collapse or what we call robustness, this was another consideration required by the building authorities. So it had to be justified that the system can perform with the omission of a major structural element, so a column in this case. And both the failure of an internal and an external column needed to be considered in the design. So a system was devised to create a horizontal tension connection between the edge beams and the floors, as well as a vertical tension pathway between the columns vertically through the height. So the horizontal connection was made through a series of cast-in lapping boxes, so in the precast edge beams. So here you can see a close-up detail here of these boxes. So they're essentially a cogged reinforcement bar which is cast into the edge beams and then bent on site. So the bars were bent into the matching pockets that were cast in the floor slabs before which obviously also lapped with reinforcement that was precast within the slabs themselves, and then it was infilled on site afterwards. Vertically, at the top and bottom of all of the glulam columns projected a large diameter reinforcing bar, which was epoxied into the timber offsite. And these were then overlapped within the grout ducts of the edge beams that they sat on. So, and this provided a continuous tension connection through the columns on every floor. So there's a detail there. You can see these steel rods going into the concrete edge beam. There was also a 30mm packing zone, which was considered at the base of the columns to allow for vertical adjustment, and then obviously this was grouted along with the ducts after the installation of each level. This is this zone here, which was poured into the grout ducts. So I'll now run through the general idea of the prefabrication and installation methodology. So starting with the CLT from Hasslacher Timber, the panels were pressed and cut in their Austrian facility before being QA checked and then passing through an automated varnishing booth. The windows, which were delivered to Hasslacher from Catspec, were then fitted, as well as the application of a vapor control membrane on the outside. And the panels were then delivered to site in that format, where they were further prefabricated on the ground before being lifted into final position. The glulam was again manufactured by Hasslacher in their Carinthia facility, also in Austria. The columns were pressed, cut, varnished, and the connections were pre-fitted before they were then sent directly to site. The Meyer Mellenhof were the manufacturers of the XC or XLAM concrete panels, as they call it. So this included manufacturing of the CLT base panel, as well as laying the coordinated reinforcement and casting the topping slab. And this was all done off-site. And then these were delivered in a just-in-time format to the site. So with the prefabrication, like I mentioned before, the wall elements arrived pre-finished internally with the external vapor control layer and the windows fitted. A facade layer of insulation linings, battens, and then a flashing piece on the vertical edges was added to the walls on the ground. And the glulam supports are then also screwed to the wall elements prior to lifting that entire pre-assembled module into the final position. So here you can see it on the ground, and here lifting the module up into final position. And this is the methodology they use for all of the walls on the project. So sometimes they had double columns, sometimes it was just a single column. And here's another view from the other side. So once the walls and beams secured and propped, the precast edge beams are connected into the top of the glulam columns via a reinforcement dowel connection, which passes through a cast-in grout tube in the edge beams. Should be able to see that going. Yep. Again, completing the entire run of edge beams before the floors went in. The TCC floors, or timber concrete composite floors, are then loaded onto those beams directly from the ground. So I think obviously this just illustrates really how much of a coordinated effort that was required to bring, essentially three major trades or suppliers together, being Hasslacher, Meyer Mellenhof, and the precaster MABA. something that obviously takes quite a lot of involvement. You might have heard before on the video, it took about 2 years in planning this project, so it was a very well coordinated job. So then infilling of the concrete blocks was undertaken after the floors were installed, and these were the only wet trades on site, obviously outside of the main in situ cores, and there was no requirement for any backpropping. So the wet trades could be taken off critical path, as by the time the grouting cured, they were spending time on the other segments of the floor. So remembering that there were five segments which docked to the main cores, which meant that they didn't need to get held up by wet trades. Here's another video of the installation, which I'll explain. You can see here the individual wall panels coming in. I don't know exactly the timing around here, but you can get a feel for how quick this was installed. Estimate that these are, they're lifting in segments every 5 to 10 minutes and building an entire floor here very, very quickly. You can see this guy here applying neoprene strips to the precast and the composite floors going in. So you'll see here on the last one, you'll be able to pick up the reinforcement, which is cast into the floor slabs and here left in the slabs ready to be grouted on site. So one particularly interesting item that I came across was the use of a heat applied bituminous membrane on top of the concrete floors. And this was applied as soon as the floors were completed, and it provided a waterproofing layer to protect the lower floors. And I know from experience of this particularly, it's a fairly contentious issue in our industry in Australia, as water management, I think, continues to elude us and be underestimated on across many projects. So this was how they tackled it. You can see it's a flame applied membrane, and these are you can see here running along the floor. And finally, as always, in keeping with tradition, the final composite roof panel to be erected is accompanied by a juvenile spruce pine tree, which is harvested from the Mainmelnhof forest, which is to complete the topping out ceremony on site. So thank you very much. Georg and I will now take some questions as well.
So yeah, thank you very much for that. A really good presentation. Really interesting project as well. Quite unlike anything we've seen in the Australian market so far. So a really good opportunity for us and obviously all the attendees to learn something a bit different, and maybe when we go out and look at our projects here, do it with sort of slightly wider open eyes. So I'd really like to thank you, Tyson, for your presentation, but then also welcome Georg to the Q&A section of this webinar. So Georg, could just get you to turn your camera on and your mic on. Hopefully, I know it's pretty late in Austria or in Germany. So there we go. Beautiful. Thank you for joining us, Georg.
Hello.
Hello. Yep, we can hear you. That's all good.
Perfect.
Beautiful. So we've had a number of questions come through just while you were presenting, Tyson. Before we jump into those, so just very quickly, Georg, I might just get you to introduce yourself quickly. Could you sort of explain your position, your experience with this project? So what your role was with this project, and then we can get into some questions.
Yes. Hello to everybody. So my name is Georg Eitler. I studied civil engineering in Graz, which is a city in Austria, and in Hasslacher Timber, I'm responsible for research and development all over the Hasslacher Group, and also for standardization and for product development. So because this project HoHo Vienna, it was a kind of research and development. So I was I was involved very much for this project in the matter of prefabrication. So this was the main idea. Was I involved in this project?
Yep, that's great. Thank you very much, Georg. And obviously, it's a really interesting project, and I think even quite unique in Europe, having such a composite of in situ concrete and precast concrete, and obviously timber, all sort of working together, and obviously grout on site, all working together to deliver a pretty impressive structure. So yeah, it's great. Thank you. So we might jump into the questions then, because we've got a few to get through, and hopefully there's a bit of time at the end and I'll be able to ask you a few of my own, because I'm particularly interested by this project. So we'll see how we go. I might ask Tyson if you know, and if you don't know Tyson, then Georg might know. Are you aware of how they dealt with the differential settlement on the project? I imagine with load-bearing timber columns and an in situ concrete core, obviously they both settle at different rates, or they both well, move as they cure, or I guess concrete moves as it cures, timber moves as it loads. Did you know anything about that, Tyson?
Yeah, so I know the obviously the glulam columns themselves, you know, have a certain amount of sort of drying or shrinkage. Obviously, in this project with the precast edge beams, there's no sort of horizontal timber fibre in like a platform construction type where that's where you get most of your shrinkage. Obviously, this is all vertical fibre, and you've got the precast in there as well. We did have the ability to use the 30mm packing zone as well to adjust as we went, but I think I might refer to Georg on maybe some specific numbering around the shrinkage of the timber and how how the team compensated for what you're referring to as sort of the axial shortening as you go up the building. Georg, do you have some comments on the shrinkage of the timber?
No, the shrinkage of the timber in direction to the fiber is very, very low. So it's only 0.01% per percent loss of humidity or moisture content. So it's really nothing.
Yep. Yeah. So obviously with the timber not moving, the concrete core is going to move a little bit as it cures, and I guess with creep over time potentially as well. Do you know if there was any particular detail utilised to connect the timber structure to that core structure that considered movement, or is it more of a project specific question?
Yes, this is very specific. This I really don't know. Yeah. But if you really have some, or if you have some questions really in this detail, you also can take a connection to Mr. Richard Woschitz, who is responsible for the static calculation. So and his for sure his guys who made the static calculation there.
Yeah, beautiful. So maybe
it's an office. It's an office in famous office in Vienna or in Austria with 150 employees.
Wow.
They calculated this kind of building.
Okay. So you'd expect this sort of stuff to be an easy one to answer for them, certainly. So maybe that's a good point. So if anyone does have any more sort of complex questions, please still put them in the Q&A, and we will follow up as best we can. And we'll post in the coming weeks. We'll post any answers on the Wood Solutions Mid-Rise Advisory Program website, so you can check back for that sort of detailed information. So I'm just going to run through the most popular questions first, and then we'll see see how we go for time after then. The next question is asking about the timber facade. So obviously, Hasslacher supplied the timber, or the CLT, which essentially supported the facade. The question is asking why did you use timber, or do you know why they used timber in that case, if it's not load bearing necessarily, and if there was any problems caused with the fire rating of the project? Yeah, either of you, I don't know which.
Yeah, Georg might. Yeah. Georg, would you like to answer that one?
Yes, for sure. The facade is for sure load bearing. Not for the vertical loads, for sure, because for the vertical loads, the glue columns are responsible. But they take the loads of the wind load. So they take all the wind loads, bring it to the columns, from the columns to the reinforced concrete beam, and from there to the ceiling, and from the ceiling to the back. To the back of the to the concrete in the middle.
Yeah, right. That makes sense. In Australia, as I'm sure you're aware, we have a lot of concern, and there's compliance requirements set out in our building code to control the use of combustible materials like timber in the facade. In this project, do you know if they had to do anything special to gain the compliance or the approval of the building surveyors or of the approver for the building?
Yeah, so the building authority, you're talking sort of more on the fire rating. We have an FRL here, or fire resistance level. Georg, yeah, you might be able to comment on the fire resistance and how the building authorities and how that was managed.
Yes, it was a really great working together. So everyone wants to make this building, which is really a building in wood. Then it will not happen. Yes. So inside of this building, for sure, there are everywhere sprinkler. Is this the right word in English?
Yep.
Yes. And this was coming from the authority, and the ways to escape out of this building are very very low. You don't have to. You are not far away from the escape ways.
Oh, that makes sense. Right, so I might move on to the next question, which has just popped up, which is actually one which I wanted to ask as well, because I'm quite interested to find out. So why did the project team elect to use a composite floor panel, including concrete and timber, rather than just using CLT floors?
This composite floor has some advantages. So it's on the one side, it's the vibrations, because you get better results in vibration. Because of the mass of the concrete, you get very, very good sound insulation. Because timber is a little bit poor in the deeper frequency of sound insulation, and so with this concrete slab of, I think, 12 centimeters, you can handle this very, very good. And also you get better results in the fire resistance with this kind of slab. And also for the span, the span is about 7 meters. And so if you add some concrete there, which is reinforced, you get also better bearing and stresses to handle with the stresses.
Yeah, it's really interesting, a very interesting system.
But I think the very important thing was to get all the troubles with the sound insulation, to make a perfect sound isolation.
Yeah, that makes sense, particularly considering there's so many different building uses within the same structure. Because I think you were saying, Tyson, there's a hotel, there's multi-res, there's offices, there's a restaurant, there's everything. Everything you can imagine.
Yep.
Yeah. I guess that ties in pretty well to a question about the acoustics of the project, and if we're aware of any other sort of acoustic systems that were utilised, if there were isolation mounts or special floor toppings or anything else beyond just the timber and the concrete.
Yeah, and you can notice in the video there is an acoustic or a sort of vibration pad, a strip that went down on top of the precast concrete beams before the slabs were loaded on. That obviously would have had some benefit there. Georg, could you explain what the build-up on top of the concrete floor was? Directly applied to that concrete, was it carpet or hardwood? Yeah.
I don't know if you have shown a picture about that. It's a double floor system. So it's separated from the slab, and I think there are 15 to 20 centimeters space to put in the installations.
Right. So for cabling and
so there's
such things,
very often we make a double floor, so under the ceiling.
Yep.
But in this case, it was not possible because the architect wants to have the view of the natural wood. So they put it up on the upside, and there the double floor.
Yep.
And this was also perfect for sound insulation for sure.
And that's like what we do here. Obviously, Lawrence, you probably be well aware as well. We do raised access floors, in situations in structures where you want to have an exposed timber soffit, and you need to achieve that acoustic performance. So you can do that by putting a raised access floor in, some insulation, some resilient mounts, and put all your services cabling through there, which is quite common.
Yeah, it's really interesting because, of course, acoustics are a key component of the design, and that can, I suppose, as we often see with fire rating in Australia, by adding a bit of mass, that does great things for the acoustics, but also you can use that product which is adding the mass for other reasons. So in this structure, obviously, it's about fire rating, it's about extra structural performance, and it's got all these double uses, which is really interesting and really good. We've only got a few minutes left, so one thing which I'm really keen to, unless I'll just double check, no other new questions, but there are quite a few there. But I'm really keen to talk about the prefabrication side of things, because I understand, Georg, this is where you have quite a lot of experience. And Tyson, you as well, of course, throughout your career. I'd be interested to know, Georg, are you aware of the impact of prefabrication on this project? Do you know how much faster it went up compared to if it wasn't, these prefabricated systems? Or do you know if there were any safety impacts or impacts on the amount of waste on site or any of those areas?
It was not it was not faster. It was for sure it was faster for sure, but it was for our customer, which was Handlerbau. It was cheaper because he saved. I know he saved much money because he has not to manipulate everything to his workshop. So he gets the prefabricated wall elements from our mills, and they go directly to the building site. And you have to know these are all some visible quality members, load carrying members, and out of wood. And when you often you manipulate them, you put them on the truck or off the truck, you can damage it. So this was always also a reason why to make such a high prefabrication inside the industrial partner.
Right, it really,
so
interesting.
It was the damaging. It was on one side it was the damaging, and one side it was the cost-intensive manipulation. When they bring it to their own workshop. So you can see on the picture on the slide here, this first one, this HoHo Next. Yes, this is the 6-story building. This was prefabricated in another way, because this was really in the workshop of our customer Handlerbau. They made the prefabrication and the facade on the on-site, and they learned there very much, and they saw that it's better to make the prefabrication at the supplier of the cross-laminated timber.
Yeah.
And what we did, we developed this varnish, this great varnishing machine in Stahl im Mölltal, where we can apply from both sides the varnish. Then we put on the wind paper, and on the other side, so it was completely finished surface, and we put in the windows in our production together in a really close collaboration with the supplier of the windows, which was Katzbeck. So we developed together with Katzbeck a very special profile, window profile on one hand, which fits to the idea of the architect, and on the other hand, which is possible for our CNC machinery to make it. This was a very small detail, but it was a great challenge.
Yeah, absolutely. I've actually, a couple of years ago
one aspect we learned, it was the prefabrication. If something not fits, you make an incorrect incorrect cutting or something like that. The advantage is you have it in your own production. Yes, you have the people there. You can show them their mistake or the mistake of the machine, and you can correct it immediately at the site, at the workshop, in the industrial industrial ground. This was a very huge advantage.
Yeah, it removes a lot of uncertainty and removes risk, really, the builder and everyone. Yeah. That's amazing. Thank you very much for that. Thanks so much, Georg, for staying up to join us. We should probably let you get some sleep now. I hope you've got a late morning tomorrow in the office.
I hope my English is not too bad, because I also can't speak very well German. So because I speak a very special dialect in German, and so English is much more heavier for me.
Okay, well, look, you've done amazingly. You've been perfectly clear. So thank you so much for joining us. We really appreciate it. And the same for you, Tyson. Thanks very much for your presentation. It was really interesting. And there are a few more questions, so maybe we'll see if we can put together some answers and post these up on our website in the coming weeks. So an opportunity for everyone, all attendees, to say thank you in the chats and show their gratitude. We'll obviously pass it on to you as well. And yeah, look forward to seeing you at future webinars and working together in the future. Thanks very much.